Lightning rods are scientifically proven to provide protection for buildings and structures. They work by providing a preferential path for lightning to travel to the ground. The rod is typically made of a conductive material such as copper or aluminum. The rod is installed on the highest point of a building or structure. When lightning strikes the rod, it travels down the rod and into the ground, where it is dissipated harmlessly. There is extensive research and evidence supporting the effectiveness of lightning rods. A study by the Lightning Protection Institute found that buildings with lightning rods are 99% less likely to be struck by lightning than buildings without lightning rods. Lightning rods are a relatively inexpensive and effective way to protect buildings and structures from lightning strikes. They are a valuable safety measure that can help to prevent damage to property and injury or death to occupants. To delve deeper into the operation of lightning rods, it's important to understand the physics of lightning itself. Lightning is a massive electrostatic discharge that occurs between electrically charged regions within clouds, between clouds, or between a cloud and the Earth's surface. This discharge seeks a path of least resistance to equalize the electrical potential difference. A lightning protection system, including lightning rods, aims to provide this path of least resistance in a controlled manner, diverting the lightning strike away from vulnerable parts of a structure. The primary components of a lightning protection system are the air terminals, also known as lightning rods, conductors, and the grounding system. Air terminals are strategically placed on the highest points and edges of a building, as these are the most likely points to be struck by lightning. The conductors, typically heavy-gauge copper or aluminum cables, connect the air terminals to the grounding system. The grounding system consists of ground rods or plates buried in the earth, providing a low-impedance path for the lightning current to dissipate into the ground. When lightning approaches a protected structure, the air terminals intercept the strike. The electrical current then flows through the conductors to the grounding system, where it is safely dispersed into the earth. This process prevents the lightning current from traveling through the building's structure, which could cause significant damage due to heat, fire, and mechanical forces. The effectiveness of a lightning protection system depends on several factors, including the proper design, installation, and maintenance of the system. The design should consider the size and shape of the building, the materials used in its construction, and the local lightning strike frequency. Installation must be performed by qualified professionals who are familiar with the relevant standards and codes, such as those published by the National Fire Protection Association, specifically NFPA 780. Regular maintenance is essential to ensure that the system remains in good working order. This includes inspecting the air terminals, conductors, and grounding system for any signs of damage or corrosion. Any damaged component should be repaired or replaced promptly. While lightning rods provide significant protection, they do not eliminate the risk of lightning strikes entirely. A lightning protection system is designed to reduce the risk of damage and injury, but it cannot guarantee complete protection. In some cases, lightning may still strike a building even if it has a lightning protection system. However, the system will help to minimize the damage and reduce the risk of injury. In addition to lightning rods, other measures can be taken to protect buildings and occupants from lightning strikes. These include surge protection devices, which can protect electronic equipment from power surges caused by lightning. Surge protection devices should be installed at the main electrical panel and at individual outlets to provide comprehensive protection. It is also important to be aware of lightning safety guidelines during thunderstorms. People should seek shelter indoors and avoid contact with water and metal objects. If caught outdoors, it is best to avoid high ground, isolated trees, and open areas. Crouch down in a low-lying area, keeping your feet together and your head tucked down. The National Fire Protection Association, or NFPA, provides comprehensive standards and guidelines for lightning protection systems. NFPA 780 standard for the installation of lightning protection systems is the most widely recognized standard for lightning protection in the United States. This standard covers the design, installation, inspection, and maintenance of lightning protection systems for a wide range of structures, including buildings, towers, and tanks. NFPA 780 specifies the requirements for air terminals, conductors, grounding systems, and other components of a lightning protection system. It also provides guidance on how to determine the appropriate level of protection for a particular structure, based on factors such as its size, location, and occupancy. The standard is updated regularly to reflect the latest research and best practices in lightning protection. To ensure that a lightning protection system meets the requirements of NFPA 780, it is important to hire a qualified lightning protection contractor. A qualified contractor will have the knowledge, experience, and equipment necessary to design and install a system that will effectively protect a building from lightning strikes. The Lightning Protection Institute, or LPI, is another organization that provides resources and information on lightning protection. LPI offers certification programs for lightning protection contractors and designers. LPI certified professionals have demonstrated their knowledge and expertise in lightning protection and are committed to following the highest standards of quality and safety. In addition to NFPA 780 and LPI, other organizations and resources can provide information on lightning protection. These include the National Weather Service, which provides information on lightning safety and weather forecasting, and the Insurance Institute for Business and Home Safety, which offers tips on how to protect your home from lightning. Understanding the principles of grounding is crucial in comprehending how lightning protection systems function. Grounding refers to the intentional connection of electrical circuits or equipment to the earth. This connection provides a low resistance path for fault currents or lightning strikes to flow safely to the ground, minimizing the risk of electrical shock and damaged equipment. In the context of lightning protection, the grounding system is a critical component that dissipates the massive electrical energy of a lightning strike into the earth. A well-designed grounding system consists of ground rods, ground plates, or a combination of both, buried deep in the soil. These grounding electrodes are connected to the lightning protection system's conductors, providing a direct path for the lightning current to flow into the earth. The effectiveness of a grounding system depends on several factors, including the soil resistivity, the size and type of grounding electrodes, and the depth at which they are buried. Low soil resistivity is essential for effective grounding, as it allows the lightning current to dissipate more easily into the earth. The size and type of grounding electrodes also play a role, with larger electrodes and is made of conductive materials providing better grounding performance. The depth at which the grounding electrodes are buried is important, as deeper burial can reduce the effects of soil resistivity variations. In addition to grounding, bonding is another important concept in electrical safety and lightning protection. Bonding refers to the intentional connection of different metallic parts of a building or structure to create an electrically continuous path. This path helps to equalize the electrical potential between different parts of the structure, reducing the risk of electrical shock and damage to equipment. In the context of lightning protection, bonding is used to connect the lightning protection system to other metallic systems in the building, such as the electrical system, plumbing system, and telecommunication system. This bonding helps to ensure that the lightning current is distributed evenly throughout the building, minimizing the risk of damage. Surge protection devices, or SPDs, are another important component of a comprehensive lightning protection strategy. SPD are designed to protect electronic equipment from voltage surges caused by lightning strikes or other electrical disturbances. These surges can damage or destroy sensitive electronic components, leading to costly repairs or replacements. SPD work by diverting excess voltage away from the protected equipment and safely to ground. They are typically installed at the main electrical panel, subpanels, and at individual outlets to provide comprehensive protection. There are different types of SPD available, each designed for specific applications and voltage levels. It is important to select SPD that are appropriate for the equipment being protected and the expected surge levels. SPD should be installed by qualified electricians and inspected regularly to ensure that they are functioning properly. In addition to lightning rods, grounding, bonding, and surge protection devices, there are other measures that can be taken to protect buildings and occupants from lightning strikes. These include installing lightning warning systems, which can provide early warning of approaching thunderstorms, and educating occupants about lightning safety guidelines. Lightning warning systems use sensors to detect the presence of lightning activity in the vicinity of a building. When lightning is detected, the system can issue an audible or visual warning to alert occupants to take shelter. Lightning safety guidelines include seeking shelter indoors during thunderstorms, avoiding contact with water and metal objects, and staying away from windows and doors. By taking these precautions, people can reduce their risk of being struck by lightning. Maintaining a lightning protection system involves regular inspections and testing to ensure its effectiveness. Visual inspections should be conducted at least annually, looking for signs of damage, corrosion, or loose connections. The grounding system should be tested periodically to verify its resistance to ground. Any deficiencies found during inspections or testing should be promptly corrected by a qualified lightning protection contractor. Proper maintenance is essential to ensure that the lightning protection system continues to provide reliable protection against lightning strikes. Understanding lightning protection standards such as NFPA 780 is essential for designing, installing, and maintaining effective lightning protection systems. These standards provide comprehensive guidelines for all aspects of lightning protection, from air terminals to grounding systems. Compliance with these standards ensures that the lightning protection system meets industry best practices and provides a high level of protection against lightning strikes. In conclusion, lightning rods are a scientifically proven method of protecting buildings and structures from lightning strikes. When properly designed, installed, and maintained, a lightning protection system can significantly reduce the risk of damage and injury caused by lightning. Combining lightning rods with other protective measures, such as grounding, bonding, and surge protection devices, provides a comprehensive approach to lightning safety. By following lightning safety guidelines and being aware of the risks associated with lightning, people can protect themselves and their property from the dangers of lightning strikes.